Hello everyone, in this video we're going to focus on top 4 FRQs using Euler's approximation that most tested on the AP Calculus BC exam. Alright, so we're going to use point slope form of equation of tangent line y equals m times s minus s1 plus y1, right? Where m equals dy over ds and s minus s1 is the step sign. Sometimes we're going to name step sign as h or delta s. y1 is the value of y the first term. Now let's move on to question 7. Let f be the function satisfying f prime of s equals -3s times f of s for all real numbers s with f of 1 equals 4, right? This one is the initial condition, right? Question B. Use Euler's method starting at s squared 1 with step size 0.5 to approximate f of 2, right? So we just get the table. Alright, the initial condition is right here, s equals 1, y equals 4, right? And you know that the step size is 0.5, right? And it's going to be ending at 2, right? So we have 1.5 and we stop at 2, right? Now we need to find the slope of the equation. So we have the slope is given by this formula, right? -3 times s times f of s, right? So -3 times 1 is going to be -3 times 4 is going to be -12, right? So equation of the tangent line is going to be y equals the slope -12 times s minus s1, which means 1, plus y1, which means 4, right? So we substitute 1.5 for s over here. We have -12 times 1.5 subtract 1 is going to be 0.5, right? Plus 4. So it's going to be -2. We put -2 over here, right? Now, new dy over ds is -3 times 1.5 is going to be -4.5 times -2 is going to be 9, right? So y equals 9 times s minus 1.5 subtract 2, right? So it's going to be 9 times s equals 2 right here. Subtract 1.5 is going to be 0.5 minus 2, right? So it could be 2.5, right? We put 2.5 right here. This one is the final answer. Now question 8, similar to question 7. I'm going to leave this one for you to practice, right? The answer is -23 over 4. Now question D. Let y equals g of x be another solution to the differential equation with initial condition g of 0 equals k, where k is a constant. Euler's method starting at s equals 0 with step size 1 gives the approximation g of 1 equals 0. Find the value of k. We're going to sketch the table. Alright, initial condition is s for 0, y equals k. Now dy over ds, we're going to use this formula, right? So it's going to be 2k plus 1. Now equation of the tangent line is y equals 2k plus 1, right? Times s minus 0 plus y is going to be k, right? Now we start at s equals 0, step size 1, right? So the final value should be this guy right here. Substitute 1 for s over here, right? So we have 2k plus 1 times 1 minus 0 plus k. And this guy actually 0 right here, right? So we just solve the equation, right? So we have 2k plus 1 plus k equals 0, right? So we have 2k plus k could be 3k equals -1, right? So k equals -1 over 3. This one is the final answer. Now question 9. This question is similar to the previous question, right? We have two step size, right? Starting as s1, -1, so we have -1 over here, and then we're gonna end as 0, right? So it could be -0.5 and 0 right here, right? I'm gonna leave this one for you to practice. The answer is 17 over 4. Now let's move on to question 10. The function f is tridifferentiable for s greater than 0 with f of 1 equals 15, f the program of 1 equals 20. Values of f prime, the derivative of f given for selected values of s in the table above. Question A. Write an equation for the line tangent to the graph of f as x equals 1. Use this line to approximate f of 1.4, right? So we have f of s equals m times s minus s1 plus f of s1, right? S equals 1, so we have the slope, which is f prime of 1, right? But f prime of 1 is 8, right? Times s minus 1, right? Plus f of 1. F of 1 is 15 right here. So we need to calculate f of 1.4. It's going to be 8 times 1.4 subtract 1 plus 15, right? So it could be 8 times 0.4 plus 15, right? 8 times 0.4 it could be 3.2 plus 15 it could be 18.2. Now question B. Use a midpoint Riemann sum with two subintervals of equal length and values from the table to approximate the interval right here. Use the approximation for this guy to estimate the value of f of 1.4. So the interval from 1 to 1.4 f prime of s ds using the midpoint formula. So we look at this one right here, 1 and 1.4 right here. We have the interval right here, 0.2, right? And this guy, 0.2, right? The midpoint is right here, right? This is the s value and the height is 10 and 13 right here, right? So we have length times width, right? The length actually f prime of 1.1 plus the width 0.2, right? Plus f prime of 1.3 times 0.2, right? Now f prime of 1.5 actually 10 times 0.2 plus f prime of 1.3 actually 13 times 0.2, and it's going to be 4.6, right? Now to calculate f of 1.4, we're going to use the fundamental theorem of calculus, right? So f of 1.4 equals the initial value is going to be f of 1 right here, right? Plus the interval from 1 to 1.4 f prime of s ds, right? So it could be 15 plus 4.6, it's going to be 19.6. Now question C. Use Euler's method starting at s equals 1 with two steps of equal sign to approximate f of 1.4. Now we're going to sketch the table. Now we start at s equals 1, right? The y value is 15 right here, right? We have two steps of equal sign. We end at s equals 1.4, right? So 1.4 is right here. This guy must be 1.2. Now to find the slope, we need to calculate f prime of 1, right? So look at the table. F prime of 1 is 8 right here. And the equation of the tangent line, it could be f of s equals 8 times s minus 1 plus 15, right? Substitute 1.2 for s, so it's going to be 8 times 0.2 is equal to 1.6 plus 15 is equal to 16.6, right? So we put 16.6 over here. Now dy over dx. So we need to calculate f prime of 1.2 is equal to right here equals 12, right? So we have f of s equals the slope equals 12 times s minus 1.2 plus 16.6. So we substitute 1.4 for s over here, right? So we have 12 times 0.2 plus 16.6, right? 19. Now let's move on to question D. Write the second degree Taylor polynomial for f about s squared 1. Alright, now we know that the Taylor polynomial expansion is given by this formula. Now since the question wants you to find the second degree only, so we stop right here, right? So we have t2 of s when s equals 1. We have f of 1, right? But f of 1 equals 15 right here, right? So we have 15 plus f prime of 1. F prime of 1 is 8 right here. Times s minus 1 plus f double prime of 1 is going to be 20 right here. 20 divided by 2 is going to be 10 times s minus 1 square, right? So it's going to be 15 plus 8 times 1.4 subtract 1 is going to be 0.4 plus 10 times 0.4 square, right? So it's going to be 19.8. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.